Hello, this is me Shankya, roll number 47, and I'm here on behalf of Group 10 to present on the topic bronzes and aluminium. The term bronze represents alloys of copper with elements other than zinc. It has usually tin as the main additive. Its discovery enabled people to create metal objects which were better than previously possible and hence started the third age, which is Bronze Age. Other than tin, elements like aluminium, beryllium, silicon, etc. are also alloyed, producing different types of bronzes. Zinc may be present in very small quantities. The simplest type of bronze consists of 88% copper and 12% tin. Other materials are also added in small quantities to get favorable properties. Bronzes are softer and weaker than steels, but corrosion resistance, heat, electrical conductivity is much better, but cost is more when compared to steels. Compared to brasses, bronze is having low coefficient of friction and high strength. It also has good castability and anti-frictional bearing properties, so it can be used in high wear and tear applications. It melts at 950 degrees Celsius. They are tough and ductile, and it retains its strength at most temperatures, and even at high temperatures. It is extremely malleable and durable. Its color ranges from dark brown to lime green due to patination, formation of a green coating due to oxidation. It is non-sparking, hence it is used in making tools for combustible environment. Its resonance property is ideal for use in casting belts. Types of bronzes are tin bronze, gunmetal, aluminium bronze, silicon bronze, and beryllium bronze. Tin bronze. It is the most simplest type of bronze and most commonly available. It has 88 to 98% of copper, 1 to 11% tin, and 0.1 to 0.5% phosphorus. Tin improves the wear and corrosion resistance of bronze alloy compared to pure copper. Phosphorus acts as a deoxidizing agent while melting to prevent oxidation and contributes to overall hardness and wear resistance. Also known as phosphor bronze. The uses are it's used in springs to get a higher spring constant, bellows to make seals and valves in pipings, also for electrical contacts to improve its conductivity, and used in bushes, in clutches and taps as it's more wear and corrosion resistant. Gunmetal. It is also known as red brass commonly, made of 88% copper, 8 to 10% tin, and 2 to 4% of zinc. Here zinc replaces phosphorus. Originally used to make guns, hence the name. Highly resistant to steam and salt water, and is easily casted and machined. It uses zinc as a deoxidizer, hence it's more cheaper than using phosphorus. It was used for making gun barrels, marine castings, gears, bearings, and propellers for marine components, as it is more wear and corrosion resistant. Thank you. And now it will be continued by S. Gopikrishnan.
Myself Gopi Krishnan. I am here to take about the topic types of bronze alloy. These are the bronze alloy: aluminium bronze, silicon bronze, and beryllium bronze. First one is the aluminium bronze. It is a corrosion resistant alloy of copper containing 4 to 15% of aluminium. With the aluminium, other small amount of metals like iron or nickel with about 6% is added, and this aluminum bronze is used to make machine parts and tools. Aluminum bronze has superior strength and corrosive resistive quality, and they have higher tensile strength than other bronze alloy. Also, they are tarnish resistant and has low oxidation property even at high temperature. Because of its low oxidation property even at high temperature, it does not get corroded easily. It does not get reacted. So these because of its high strength and corrosion resistant property, these are used in marine hardware, shaft, pump and valve, component for handling seawater, sour mine waters, and non-oxidizing acids and industrial process fluid. Mainly the industrial process fluid contain the fluid which can cause corrosion. So aluminum bronze is a good alloy in order to prevent corrosion. Next is the silicon bronze. Silicon bronze is a low-lead brass alloy that is generally composed of 96% of copper, and with that remainder metal like silicon and variety of other alloys such as manganese, tin, iron or zinc, like that. It has high strength alloy. Also, it has easy pouring ability, high corrosion resistance and appealing surface finish. The silicon bronze was originally developed for chemical industry, later expanded due to its good casting characteristics. It has an attractive reddish color due to which it is used in architectural and decorative purpose. One of the main disadvantages of this silicon bronze is that it is expensive and difficult to be recycled. In order to remove the matrix from alloy process, it is difficult. So the silicon bronze is typically used for gas tungsten arc welding, gas metal arc welding for copper, brass, bronze, steel and galvanized steels and also cast irons. Next one is the beryllium bronze. It is a copper alloy with 0.5 to 3% beryllium with other elements. This alloy combines high strength with a non-magnetic and non-sparking quality. Also, it has excellent metalworking, forming and machining properties. It is corrosive to chemicals, and one of the peculiarity of beryllium bonds is it can be softened and hardened by applying heat. So it can be increased in strength by applying heat. It has many specialized application in for making tools for hazardous environment, musical instruments, measurement instruments, like that. It is also a good conductor of electricity and heat. One of the disadvantage of beryllium bronze is that it is dangerous if it does not handled properly. The inhalation of the beryllium bronze dust particle of beryllium bond can cause lungs problems and like that. Thank you.
I am Shanti Xavier, roll number 49. I am here to present about aluminum and its alloys. Aluminum occupies the third place among commercially used engineering materials. The characteristic features of aluminum are its low density, low melting point, high electrical and thermal conductivities. It has low strength and hardness but high ductility and malleability. On exposure to atmosphere, aluminum forms a strong film of aluminum oxide on its surface, which prevents further oxidation and corrosion. Properties: aluminum has good machinability, formability, workability, and castability. It is also non-magnetic, non-toxic, and easily available. It is less expensive compared to other metals, but the main drawback of aluminum is its low strength and hardness. Some other properties of aluminum include non-corrosiveness, lightweight yet durable, non-magnetic and non-sparking, good heat and electrical conductor. Application of aluminum as a structural material is limited by its low strength, but it is employed for lightly loaded structures and for electrical cables and similar items. It is used for making heat sinks for electronics and foils, beverage cans, etc. Several alloys and composites use aluminum as the major raw material. These are some images which shows the various use of aluminum in different fields. Alloys of aluminum. As aluminum on its own has very low tensile strength, the addition of alloying metals like copper, manganese, magnesium, silicon, etc. can increase its strength up to 4 times by forming solid solutions. There are mainly two principal classifications of aluminum alloys: which are cast alloy and wrought alloys. Both are further classified into heat treatable and non heat treatable alloys. Uses and limits. Aluminum alloys are widely used in automotive engines, particularly in cylinder blocks and crankcases. As aluminum alloys are lightweight, they are also used for making aircraft parts. Some major limitations of aluminum alloys are their loss fatigue strength compared to steel. Also, the greater coefficient of thermal expansion causes it to expand and contract depending on the temperature conditions. Some examples of aluminum alloys are cast alloy, wrought alloy, duralumin, Y-alloy, magnesium, silicon alloys, etc. The different aluminum alloys will be discussed in detail by Nitin, Siddharth and Sri Siddhi. Thank you.
A good day to all. Myself Siddharth, roll number 50. So I'll be dealing with wrought aluminum alloy and casting aluminum alloys. So wrought aluminum alloy. So these are cold work metals that are plastically deformed to bring about a change in shape or structure and their mechanical properties. So cold work means that they are worked under temperature below the crystallization temperature. So production. So as we can see, wrought aluminum is produced by smelting pure aluminum ingots with the specific alloying elements uh, required to make a given grade of aluminum. And these metals is then casted into billets, and then they are either rolled or forged or extruded into its final shape. So properties. So depending on the composition of different materials, properties of alloys drastically changes, like properties like ductility, malleability, tensile strength, etc. So as we can see in the figure, a wrought aluminum alloy can be identified by fourth digit method. The first digit will indicate the principal alloying element and is thus the most important. And the second, unless it's a 0, indicates a modification of the alloy, and the third and the fourth digits are identification numbers for the specific alloy as shown in the figure. So based on this composition of different materials, they have different tensile and yield strength. So we can see in the figure that a few examples are given in the figure. So applications. So they are applied in aircraft airframes, electrical bus bars, motorcycle frames, etc. So these rods are mechanically rolled by a roller, and these sheets are mechanically flattened. So casting aluminum alloys. So they are made at temperature above the crystalline temperature of the metals and is molded into shape. So it contains larger percentage of alloying elements when compared to wrought aluminum alloy. Cast aluminum also has a generally low tensile strength than wrought aluminum due to the difference in difficulty in eliminating casting defects. So production. Casting aluminum alloy is produced from bauxite. So this is the natural occurring minerals containing 15 to 20% in the aluminum, and is the only ore still used for commercial aluminum extraction. This process of extracting pure aluminum from bauxite is highly complex and energy intensive. So properties. So as we can see in wrought aluminum alloy, in cast aluminum alloys, the only difference is is that in along with the numbering system, they have also included a decimal point after the third digit. This system was developed by the developed and maintained by the Aluminium Association, and is most widely used. And applications. So the cast aluminum alloys are used as gearbox housing, axle housing, cast wheels, window fittings, etc. So thank you, and over to Nitin.
Hi guys, my name is Nitin Mohan, roll number 51. I will be taking topics based on duralumin and Y-alloy. Simply giving an introduction, Y-alloy is a nickel containing alloy and duralumin is an aluminium alloy containing 4% copper. Both of them are well known for their strengths, and that's one of their main properties, or you can say that's one of the best traits. Now coming to our first topic, duralumin. Duralumin, as you can see, it's called by a variety of names. Duraluminium, dural aluminium. There are a variety of names. Duralumin is a trade name for one of the earliest types of age-hardenable aluminium alloys. Its use as a trade name is absolute, and today the term mainly refers to aluminium copper alloys. They are called by both the names together. Designated as the 2000 series by the International Alloy Designated System IADS, as well as they were used by the 2014-2025 alloys for airframe fabrication. In addition to aluminium, the main materials in duralumin are copper, magnesium, and manganese. For instance, aluminium 2024 consists of 91 to 95% aluminium, 3.8 to 4.9% copper, 0.3 to 0.9% manganese, 1.2 to 1.8% magnesium, lesser than 0.5% iron, lesser than 0.5% silicon, lesser than 0.25% zinc, lesser than 0.15% titanium, lesser than 0.10% chromium, and no more than 0.15% of other elements together. When we are coming to the history of duralumin, duralumin was developed by the German metallurgist Alfred Wilm, and he discovered that after quenching, an aluminium alloy containing 4% copper, which we said in the beginning, would slowly harden when left at room temperature for several days, and further improvements led to the introduction of duralumin in 1909. The name is mainly used in popular science to describe the aluminium copper alloy system or 2000 series as designated by the International Alloy Designated System, as we all said. And its main uses, typically uses for wrought aluminium copper alloys include in the 2011 criteria, wire, rod, and bar for screw machine products. They are used in the machine products. Then they were used in major structural components like space booster tankage and structure, truck frame and suspension components. The applications requiring high strength and hardness, including service at elevated temperatures. This was at the 2014 criteria. 2017 or avional, around 1% silicon, good machinability, acceptable resistance to corrosion in air and mechanical properties. They were used for aircraft application between the wars in France and Italy. That's one of the main uses of 2017. Also some use in motor racing application from the 1960s, as it is a tolerant alloy that could be press formed with relatively unsophisticated equipment. 2024 criterion includes aircraft structures, rivets, hardware, truck wheels, screw machine products, and other structural applications. 2036 sheet for auto body panels, and 2048 sheet and plate and structural components for aerospace application and military equipments. Now coming to why alloy. Y alloy is a nickel containing aluminium alloy. We said it in the beginning. It was developed by the British National Physical Laboratory during World War I in an attempt to find an aluminium alloy that would retain its strength at high temperatures. We told in the beginning that they are known for their strength, and this is what it indicates. Duralumin, an aluminium alloy containing 4% copper, was already known at this time, which we said in the beginning. The National Physical Laboratory began a series of experiments to study new aluminium alloys. Experimental series Y was successful, and that's why the name came. This addition of nickel was an innovation of aluminium alloys. These alloys are one of the three main groups of high strength aluminium alloys. The nickel aluminium alloys having the advantage of retaining strength at high temperature. That is like duralumin. We told that there's 4% copper alloy, and in addition to that we had 2% nickel and 1.5% of magnesium. Now coming to the composition of aluminium. Aluminium is a major proportion, 92.5%, copper 4.0%, nickel 2.0%, and magnesium 1.5%. We can see that the strength criteria is divided among these materials. Now coming to the heat treatment. As for many of the aluminium alloys, Y alloy hardens spontaneously at normal temperatures after solution heat treating. The heat treatment is to heat it to 500 to 520 degrees Celsius, that is 932 to 968 degree Fahrenheit for 6 hours, and it gradually cools down to 7 to up to 7 to 10 days, which takes 7 to 10 days. The precipitation hardening that takes place during this aging forms precipitate of both CuAl2 and NiAl3. The times required depend on the grain structure of the alloy, the grain size. Forged parts have the coarsest euteric masses and so take the longest times. When chill casting is favored over sand casting, as this gives a finer structure that is more amenable to heat treatment. Thank you.
Myself Sri Siddhi, roll number 52, and I'll be taking the topic magnesium and cesium. Magnesium. Magnesium is an aluminum alloy with 5% magnesium and 95% aluminum. Properties. Alloys with small amount of magnesium, about 5%, exhibit greater strength, greater corrosion resistance, and low density than pure aluminum. Such alloys are more workable and easier to yield than pure aluminum. Alloys with high amounts of magnesium, about 50%, are brittle and more susceptible to corrosion than aluminum. Other properties include high strength, low density. These alloys are flammable when powdered. They are more resistant to corrosion than pure magnesium and are more reactive than pure aluminum. Due to high reactivity, magnesium burns comparably hot and forms bright yellowish white sparks. Magnesium powder also burns with a cracking sound, if burned by itself, provides a good compromise between reactivity of magnesium and stability of aluminum. The alloy is brittle. It is easily broken with a hammer. It will grind in a ball mill into fine powders in a matter of hours as opposed to a matter of days with aluminum powder. Uses: aircrafts and automobile parts, used in pyrotechnics as metal fuel and to produce sparks. Cesium. Cesium is a general name to group of lightweight, high-strength aluminum alloy based on aluminum silicon system. Aluminum silicon alloys typically contain 3 to 25% silicon content. Casting is the primary use of aluminum silicon alloys, but they can also be utilized in rapid solidification process and powdered metallurgy. Properties: alloys used by powder metallurgy rather than casting may contain even more silicon, up to 50%. Cesium has a high resistance to corrosion, making it useful in humid environments. Addition of silicon to aluminum makes it less viscous when in liquid form. Hypereuthertic alloys with a silicon content of 16 to 19% can be used in high-wear applications such as pistons, cylinder liners, and internal combustion engine blocks. Characteristics: high castability, fluidity, corrosion resistance, ductility, and low density. Usable to large casting which can operate under heavy load condition. Considered to not be a heat treatable alloy, but the addition of magnesium and copper can allow it to be heat treated. Uh, Alloy can be strengthened by solution treatment. Example: adding 0.01% sodium in the form of sodium fluoride and sodium chloride to melt just before casting. A disadvantage is the tendency for porosity in the casting. That is, casting can become foam like. This can be avoided by casting under pressure in autocars. Thank you.